Hi folks, welcome back. I hope you're all doing well. Very soon after ChatGPT came out and people started realizing the kinds of applications you can use LLMs for, it became obvious that one of the biggest applications would be education, that everyone would have a personal AI tutor. But how exactly would you do that? That is the question that this paper looks at. It's from authors at Google. It came out around the same time as Google I/O earlier this year. And it looks at how you would construct an LLM that is good at pedagogy, at being used as a tutor. Now, this is a very detailed 80-page long paper, and I'll just be cherry picking a few key things out of it. I do encourage you to read the full paper. The two main things I want to talk about is, number one, how do you define what good pedagogy is? What makes a good AI tutor, and how do you measure that? And to do that, they've defined such a rubric and then a benchmark to measure that. And number two, once you have that rubric, how do you construct such a model? And that is their second big contribution, where they fine-tune an LLM to be a good tutor. To start with, to understand what makes for good pedagogy, the authors spent time with students and teachers, and these are some of the high-level principles they came up with. The first is to not simply give the answer. You have to encourage the learners to understand the material and come up with the answers themselves. Have clear and easy to understand explanations. Encourage students. This one is important. The tutor has to recognize when learners are struggling with something and help them get unstuck. It should ask questions to determine if the learner is actually understanding something or not, and offer them step-by-step explanations for concepts. And we'll see later how all these principles make it into rubrics for evaluating good pedagogy. Now, you might wonder, why couldn't you just construct an LLM tutor with a very elaborate and detailed prompt? And indeed, that is what a lot of products that are currently on the market do. However, on looking deeper, the authors here found a lot of limitations with simply prompting an LLM to be a tutor. The first one is that your prompt has to be really detailed, and you have to explicitly enumerate a lot of behaviors that you want to see or that you want to avoid. And they found that simple prompting results in inconsistent and unreliable results. And so what they're proposing here is to fine-tune a large language model to capture all the nuances of a good tutor. They constructed several fine-tuned models. The first few of those used PaLM 2.0 as the base model, and then the last one, the one they call M4, used Gemini 1.0. Now, the authors do recognize that as newer foundation models are coming out, they are getting much better at following instructions and prompt. They're much more steerable. And what they found was that their fine-tuned model, M4, which was fine-tuned on top of Gemini 1.0, the gap between M4 and a simple prompt-tuned Gemini wasn't that great. The prompt-tuned one was better, but it wasn't vastly better. And so the authors are circumspect enough in this paper to acknowledge that this situation might change with future foundation models. All right, so here's the key part. Now that they decided that they need to fine-tune an LLM, the question then becomes, what is the data set for fine-tuning? And the authors have used 4 data sets. The first one is a data set formed out of human tutoring. They collected conversations between human students and human teachers that they enrolled and they were paid for their time. Notice that the authors here acknowledge what the limitations of this human data set are. The conversations are not specifically targeted to teaching, so they're mostly about teaching, but the conversations might touch other topics as well. And the quality tends to be uneven. The second big data set is role playing with LLMs themselves. So you set up two LLMs, one plays a tutor, one plays a student, and you prompt them for each of those roles and you have them talk to each other. And then the third data set is the dialogue version, the Socratic version of GSM 8K. GSM stands for Grade School Math. It is a benchmark consisting of math word problems. And within that benchmark, there's a subset that contains conversational step-by-step explanations of the problem solutions. And then number 4, the final data set is what they're calling golden conversations. And this is their highest quality data set. In this, they explicitly asked teachers to specifically write out conversations to explicitly demonstrate what good teaching behavior looks like. So these were not organic conversations. These were conversations specifically meant to demonstrate good behavior. Using those data sets, they constructed a fine-tuned LLM, and then we get to measurement. The rubric they use for measurement is based on the principles we just talked about, things like encouraging learning, managing cognitive load, which means explaining things in manageable chunks, metacognition, which means to explain things in a way that enables learners to generalize past the specific topic being taught, encouraging curiosity, and being able to adapt to the students' goals and needs. Now let's look at some results. The first set of results is from human evaluations, both from students and teachers. This graph shows feedback from learners, subjective feedback, and you can see how along most dimensions, the Learn LM model, the fine-tuned model, was preferred over a simple prompted Gemini 1.0 LLM that was not fine-tuned. This graph shows feedback from teachers, and it's a much more mixed picture, but on the engagement axis, you see that the fine-tuned model is much better and it's statistically significant. Now you can see here, for being encouraging, they actually got a negative result for the fine-tuned model. And the authors are explaining this in terms of succinctness, in that the fine-tuned model was tuned to give shorter answers, whereas the untuned 1.0 LLM was much chattier. Those were human evaluations. The authors also constructed a bunch of LLM critique evaluations. And one of the cool contributions of this paper is to actually provide the prompts that they used for LLM as a judge for pedagogy. So the appendix has the full prompts that they used for their automatic LLM evals. Here you see results for the automated evals using LLMs. This graph on the left shows rough agreement between human and LLM evals, just as a sanity check for validity. And this graph on the right is showing how along most dimensions, the fine-tuned Learn LM model rates better than vanilla Gemini 1.0. So that was a very quick, abbreviated look at an approach to fine-tuning an LLM to be a good tutor. And here the authors are showing that you really have to fine-tune as opposed to using a prompted approach. They construct a full rubric for what makes for a good tutor, and then they fine-tune for that and they measure for that. And so it really is a very rigorous piece of work. The authors do acknowledge that this main finding might change with better models in the future, where prompted approaches might be as good as fine-tuning if future models are much more steerable. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you next time. Thank you very much.